Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2023. Last day of Formnext, and of course, we save the best for last. We have an exciting panel discussion for you on the topic on design for AM. So imagine there's this one part that you want to optimize, and you start thinking about a possible design, and immediately they are there. The demons that keep catching up with you, such as that won't work because that can't be made anyway, or that won't work, it will take too long, or that won't work because, etc., etc. So then at some point you come across this rare phenomenon called additive manufacturing, and you suddenly realize what is possible if you just let go and fully embrace it. That, ladies and gentlemen, is the moment when you enter into design for additive manufacturing. In our panel for design for additive manufacturing, we want to talk to experts, much more than I am, about the various aspects that limit us, but even more about the aspects that give us completely new opportunities. Please welcome with me here on stage, to my left, Mr. Thomas Lück. Thomas, good to have you here. Head of Sales and Innovation at SIRP. Then we have Mark Beecroft, Senior Lecturer Textiles in Practice at the Manchester School of Arts. Hello, Mark. Good to have you. Kenny Delgado, Professor of Manufacturing Engineering at the Newcastle University. Kenny, good to have you. And then Dr. Mahdi Bodagi, Senior Lecturer in Mechanical Engineering at the Nottingham Trent University. Mahdi, good to have you. And last but not least, Alex, today 5 in our panel. Alex Kimber, Director of Alex Kimber Design. Good to have you all with us. Good to have you. Alex, you're the designer here. No, you're all designers, but you are the designer. Before we get really deep into the topic, my question to you, how would you explain what design for additive manufacturing is to someone who doesn't come, like me, from an AM background?
Well, I would say there are parallels towards design for manufacture in more traditional industries, in the sense that we're trying to leverage design to make the manufacture of the part both easier and more efficient. But I'd say there's two things to note that differentiate design for additive manufacturing. One, which was noted in Connor's presentation earlier, it's a holistic process. And I think that's due to the economic differences and the scale of complexity. You have to consider design for additive manufacturing throughout the entire development process. And I'd say secondly, there's a very different mindset, if not a complete inversion of the mindset compared to traditional processes. So to take an example with CNC, you want to try and reduce tool paths, but that's not a problem in additive manufacturing. Complexity is fine. You want to reduce materials. So yeah, I would say you want to have a holistic mentality that's very different to more traditional processes.
Very good definition. And Patrick, today in our morning talk, he put it that way, as he said, it always depends on the aspect you are looking at. If you want to reduce cost, then or on the feasibility of application, then you consider a design for AM in another way than probably for another application of you, at least. Mark, in your work, you specialize in textiles with a focus on knit structures. The funny thing is, yesterday at the party, we had a 3D printed dress, indeed. Have you seen it?
Possibly, yeah.
Yeah, it was. They had LEDs all on it so that you can't miss it, basically.
Okay.
But it was really amazing to see. So, in your opinion, why is design for additive manufacturing so important in your work? And furthermore, what would be interesting for me at least, what is the influence of AM in textile manufacturing?
Okay, so within my own practice, this exploration of knit-based structures and AM is really important because it enables a reconceptualization or a reimagination of what knit is in terms of what the structures are, what they do, how they behave, and what they might be used for. So I think coming from more of a design art background than engineering, it's this kind of what if, what happens if, and then how might these applications result out of those explorations. So I think the relationship between AM and textiles is quite complex. Obviously, textiles are very established forms of production. AM does offer opportunities, but I think it's exploring what those new behaviours are that don't replicate existing textiles, but take them beyond and offer something new, novel. And then the next question is, so what? What's the use for them? Is there a use?
To summarize it, is a little bit the entrance door into new innovations in textiles, basically, isn't it? Yeah?
Yes, yes. So I think there is an application. I definitely don't think it's to replace mainstream fashion or garment production. I think it's finding those bespoke, high value, important enough applications that would warrant the technology.
The funny thing is, Marty, you might not know it, but that led me to you during my research up front. No joking, because you go one step further. You even look into the possibilities of 4D printing, which, at least from my knowledge point of view, is very future orientated. Yeah? So to what extent does this make a design process even more complicated, and what are existing use cases beside textiles?
Yeah. Okay, thank you. I think design for 4D printing adds complexity because it involves the change in the material properties over time, during the printing and even after the printing. However, it opens a lot of opportunities for us to create adaptive structures that can change the shape over time. So it's a lot of opportunities. Yeah.
So I was wondering, Marty, considering what Alex says about design and Mark as well, so I have to consider the whole process chain, which is complicated enough from my point of view. And then you come, Marty, and say, hey guys, we can even change the structure over time. What is the challenge in design though? Because this gets a complexity that is really hard to handle, isn't it?
So the challenge actually is in the creating a feature. So all of the AM kind of parts are static, but we would like to create something that's movable, that can change the feature over time. So it's very challenging, and I need to give an example. For example,
Yeah.
For example, imagine you create a metal materials. The materials can change the shape.
Yeah.
So we need to do a lot of the forward thinking, how we can combine the small materials with the 3D printing. How we can control the features, for example, the change in the shape over time. So a lot of challenges. Yeah.
Kenny, basically, you are one of the users, basically, of this in the future, probably, because you deal a lot with medical things printed out of 3D, right?
Yeah.
So we can already realize many things, as far as I've seen. We discussed some of the possibilities here on stage already that we wouldn't have dreamed of in the past, to be honest. And I'm dreaming a lot, so you are my big hope for the future, Kenny. I hope you do that. So what can already be done, and what role plays design for AM in this?
So we can and do produce lots of medical devices using additive manufacturing techniques. And they're within healthcare services. They're being delivered. Lots of them will be delivered today and tomorrow and the next day, whether they're externally applied prosthetics or hip implants or knee implants, those kind of things. So there's lots of evidence that we can generate very useful medical devices using AM. The challenge now, and the challenge that is a design for AM challenge, is scalability.
Yeah.
We need devices that work clinically, that work technically, and that work commercially. Everybody's healthcare system is under pressure, and so we need to be able to deliver devices throughout healthcare systems at prices that the healthcare systems can afford. And that means setting out with the objective of designing something that can be scaled and the automation of the design process, rather than seeing it as a one-off design process. It has to be, okay, how do we make this work for the population as a whole? And that's a kind of different design challenge, but unless that's your starting point, you never get to the stage where you can actually make it technology that's accessible to a broad brush of the population.
And this tackles again one point you mentioned, Alex and Connor, as well this morning. You have to again consider so many more factors than just, is it feasible, can I print it, it must be affordable at the same time for a broader range of people. But before I step into design as well, when do I get my knee implant at a low cost?
At a low cost? Well, to be fair, there isn't a knee implant at a low cost. There are more expensive and less expensive.
Yeah.
I think that's it. But you can have a knee implant at a low cost, relatively low cost tomorrow, but it won't be a 3D printed one.
We need one of those.
Yeah,
I stay with my.
If you keep your knee for the moment. But actually, I mean, prices are coming down, and it is about the amount of time that goes into the design process. If you have something which is, if you like, already quite expensive, and then you have to pay a very talented designer for hours and hours and hours of effort, you're making it more expensive. And so automating the design process in the kind of way that Connor talked about earlier, and in the way that we've seen happen in the prosthetics industry, is definitely the way forward. That's the way that it becomes lower cost, that you get to the stage where the design of the component isn't outweighing the cost of making it, in fact.
Yeah.
So it is a design problem to get that scalability through.
And that brings me to you, Thomas, because the funny thing is, when I heard Connor's speech, I was like, wow, this must be cheaper though in the future. Don't get me wrong, because I thought, okay, let's get into the hospital. You have the standard knee implant that you get, and then after like 3 or 4 years, or 5 years, you need to exchange it to the next one and then to the next one, because it has not the durability in terms of your bones, etc., connected to it. And then you have pretty much your own reprinted that should be more durable and therefore much cheaper. So this brought me to you. We are dreaming of all that is possible, of course, but there are some constraints and obstacles. But what are the real challenges of design that you are seeing?
Well, we as a service bureau, printing parts for other people for 30 years now, we receive a lot of designs. And sometimes we have to say, no, it's not feasible. And reason for that is that this belief everything is possible, it is not. And of course, it depends also on the method we have. For example, 3D printing techniques which work with support structures. So designing, you have to take that into account. And we have 3D printing techniques which work without support structure. There you have some extra freedom, and we need some minimum wall thicknesses and other topics. And also we need to talk about quality issues, so tolerances, surfaces, requirements. And if you come with a drawing which originally was made for another more conventional technology, more conventional manufacturing technique, then there can be a clash between these requirements and these nice but not endless possibilities. And sometimes then we have to give recommendations or refuse some of these requirements.
Alex, taking this from Thomas, is it sometimes disappointing you as a designer? You have probably a great idea for a problem that could be solved, for one of Kenny's, for example, yeah? And you solve it as a designer, and then Kenny gives it into a process of testing and quality, and they say, it's not feasible. Or Thomas, as the one that probably needs to print it, says, don't get me wrong, this is not feasible. Is it sometimes frustrating, and is it challenging at the same time as a designer to know all this around? Because
I think it is frustrating, but that is part of the process. It's baked into the process. I think the relationship, which is quite stereotypical between designers and engineers, and is almost a bit of a joke, is there's a grain of truth to it, and that tension is actually where the magic happens. So even though it can feel frictional, even though it can feel like, why don't you appreciate my great idea? That friction is where the magic happens. So I think it's something to step into and to celebrate and to say, this is a collaborative process. I don't have the knowledge and experience of the manufacturers and of the distributors, and they might not have the full context of the design brief that I'm trying to satisfy. But between us, we can wrestle out a solution.
Kenny,
Yeah, I was going to say, and I agree with you. But actually, if you've got a good design process, you don't get to that place.
okay.
Because you have a conversation and a set of jointly agreed requirements, an understanding of where you're all going at the beginning. And that's a kind of well-structured, recognized kind of design process. Things tend to go wrong when you don't do that.
Yeah.
And then you can get lost in different expectations and different places going. But that key element, we teach all our undergraduate students, you start with requirements, you get them agreed, you do that. That's always the place to start, so that everybody's kind of looking at the same problem from the same viewpoint, hopefully.
But I would agree to these magic moments, maybe rare, but to these magic moments when we want to take the potential and really see what happens if you are open. I agree. A proper
it's in
design
conversation,
process, a
isn't
proper product development process has to start with requirements and your right milestones and so on. But if you want to create something totally innovative, then that's your chance to say, okay, then that's your chance to say, okay, let's think out of the box, let's play, let's do something totally strange and see what happens. And there the combination of different disciplines helps a lot.
Yeah,
I think
agreed.
I'd like to layer onto that. You have your requirements list, but I think you also have a communication issue about purpose. So you have the requirements list and you have metrics that you're trying to achieve, but I think you have to contextualize that and say the reason why we need to achieve this metric,
Absolutely.
or even the reason why we can have a trade-off relationship and bin off that metric is for a particular context, whether it's brand or maybe a tolerance stack within an assembly or some other reason.
But Mark, leads me to you. I mean, considering textiles, we do not have only the functional side. This would be great. I would be very pleased if we forget about the how it looks like aspect. But there's always a percentage of art in it in textiles. I've never seen a textile that's not at least been considered a little bit. How does it look in the? There's a friction as well, isn't it? I mean, and how do you deal with that in design for it?
Yeah, we were just talking about this before, actually. I think it's difficult because the potential for all this algorithmic, otherworldly designs that look, very computerized, but then how many people actually want to wear those or are happy to look quite alien or other off the catwalk or Met Gala type incident? I think it's questionable. So yeah, there's aesthetics, obviously, but I think just picking up on the idea of the parameters and knowing what you want, not to plug a bureau that I used to work with, but all of my research would have stopped about 8 years ago if I wasn't accepted by a bureau that said, these might work, we're not sure, but we're willing to have a go. And I think taking risk and making mistakes is when innovation can happen. So we encourage our students to try things even if they may not work, or try to do things on the printer that it's not designed to do, because I think that's when innovation happens. So in a speculative field, I think to push textiles forward, it's about pushing the boundaries. If you stick to what the guidelines say in terms of tolerance and all support and things, then a lot of the work I've done wouldn't exist. So I think it's having that collaboration, working with the designer, working with the bureau that's willing to take those risks to push the field forward.
But Kenny, I need to ask you though. I mean, in your field, pushing the boundaries is kind of restricted, isn't it?
Well, then, and a regulator said, well, you have to prove that it works.
Yeah, before.
That's all.
Yeah.
and that's kind of and there are recognised systems that you have to go through to do that through the regulatory structure. It's important that it's done because it's important that we provide devices that are fit for purpose and that can be brought through and expanded out to market in a good way. And I think, over the last 4 or 5 years, the various regulators have started to engage a bit more in terms of understanding how to regulate around additive manufacture of medical devices. And so there's particular processes for custom devices. The FDA in the States now have a kind of semi-formal process of you identifying your core product and then identifying the degree to which you can customize it for an individual patient. And so there are ways of doing it, and definitely ways of doing it. But if you set out to make medical devices with a mindset that you don't want to approach the regulatory system, then it never gets to market. It's as simple as that. I would always say we should be happy that we have a regulated healthcare system, that we know that that things will work when they're given to our parents or our children or our grandchildren. That's important to us, I think.
I like this view, Kenny, to be honest, but on the same time I'm very impatient, so sometimes forget about the regulation. Matti, where do you see the connection between design for AM and 4D printing? 4D printing, in my opinion, really is the next step we will see. It has a lot of challenges, but there, especially if it comes to medical devices, as you mentioned a few, probably you can tell us some use cases, then you're not only facing regulation or testing, you have the more complex technology approach, right?
Yeah, so synergy between design for 3D and 4D printing lies in kind of minimizing the resources, materials we use, reducing the waste, and also kind of energy consumption. And when it comes to the biomedical applications, I think 4D printing can help a lot. Imagine we can create self-expanding stents. These are on the market actually, so it's a current use case. And when you, for example, when the surgeon puts it in the catheter, they send it to the required location, so mostly in the heart. And once they push it out, so because of the blood temperature, it's activated, so, and it expands automatically and opens the blocked arteries. So I think 4D printing can help a lot, especially where it's very difficult to do a lot of the operations. So that's one of the examples.
To be honest, it scares me a little bit because, especially considering a stand, I mean, put it on the wrong place and it start expanding would be not a nice thing to see. Thomas, Connor mentioned this morning, and I like this very much, the challenges, especially if it comes to software now, CAD software and construction and design, for how it's limited. How do you see the progress in this regard? And where are the restrictions right now with the software available in Design for AM?
Well, the simple parts, I believe you can use the tools, you use further manufacturing techniques as well. But if you want to really find extra potential with complicated lattice structures or with individualized, like Kenny says, individualized products, then you can't afford conventional design and the conventional design software. It will make a product far too expensive. So you have to make the computer do your work to make it affordable. And we have done something like that ourselves, like others did. So this helmet is specially made for me. I have a special head form. So the normal, it's all.
Oh, you don't. You don't.
No, it's very long and narrow, my head. So that's specially made for me, part of a research activity, European funded. And if you want to do something like that with just normal CAD software, it's a nightmare. Now we have to find affordable solutions so that you don't have to spend 50,000 euros, pounds, or what per year if you need it only a few times. And we see a lot of things coming up there on a low level and on a sophisticated level. So that's moving forward. We have to make sure that people who want to try things can entry that at an affordable level.
Okay. And, thank you. Further, let's see whether this helps or not. In fact, Connor mentioned then, if you don't have the means to do it the classic way, let's put it that way, then engineers and designers in the future need to learn coding. Mark,
Exactly.
Mark, how firm are you with coding already? Be honest.
Not very. I think this brings me back to, no one person or designer can do everything. So I think definitely within textiles and fashion, I think collaboration is the only way forward. So a textile designer or fashion designer will collaborate with an architect or a coder or an engineer, because you can't feasibly do everything or know everything. And I don't think you should try to know everything, because textile and fashion skills lie somewhere else. It's how the relationship, when that's applied to coding, becomes really exciting. So I think a fundamental basic understanding is key to enter the workplace, but then I always think you'll work in a collaborative team. So within textiles and fashion, you won't be the sole person expected to do it all.
So basically you need a translator though, right?
You need a team,
Yeah.
collaborative team.
Yeah, no, I know, but at least, I mean, you do the design, and there must be somebody, probably you, who is the door into a coding world and translate what you have in mind to that. Kenny?
Yeah, no, I mean, conventionally, if we get to automation, you'll identify your product and then decide what you want to allow to be customized, whether it's shape, stiffness, and all those kind of things. And you can build a system around those parameters and generate that quite early. The difficulty, the bit we're probably not seeing yet is a kind of generic configurator. So which and they do exist in some industries. Semiconductors have used it, and various other places where it gives you the architecture to decide what you want to customize, and then allows you to build an application around it, so that for your specific product you can build into something. I think we are seeing the product focused, the kind of single product orientated configurators, particularly for externally applied devices and some implants, that kind of those design rules, if you like, are set down and can be implemented. But it would be really good to see a more generic configurator type of software product that would allow people to develop their own instance cases around those kind of products. And I don't think we've seen that yet. Certainly, if it is out there, I haven't seen it. I don't know, Thomas, you might have. If you've seen anything along those lines, it was something I would like to see.
It's at the moment really in a design room, as you say, and then you can configure it within that, and you have to design that. But other than you said, we were lucky here that the designer was interested in learning coding for quite some time, so that the design and coding went into the same person doing it.
Mm-hmm. All this coding, talk about, I used to be good at coding. I think is where I am with that. That's the main thing.
You can reuse it now. That's for sure.
I need to refresh my.
The two of you are from the research area. Yeah, you are two basically from the research area, although very much into practical use as well. So, is there a way you can push it? I mean, you are in the need of new tools, new softwares, etc. And is that something you discuss in the design for AM network, for example? Is that something you invite companies or suppliers into a collaboration? What is going on? And what is the current status about that? Probably, first you. Then I have another for Alex in the same direction, but please,
Well, I can't name the company, but we have purchased a printer that prints directly onto fabric, so probably giveaway. And there is talk about developing a software that will enable 2D designs and drawings to very easily be translated into the 3D CAD. And I think for textiles and fashion, that's a massive leap forward. Not to undermine the understanding of 3D CAD, because I think students need to understand it, but I think that step is one of the biggest hurdles for textile and fashion researchers or academics, that translation of the CAD. So I think any programs or plugins or things that enable that to speed that process up will enable us to focus more on the creative side of the designs.
Yeah, very good. What about you two? Same experience?
In terms of going on, I think we see we see needs, I think, in terms of that, and I think we've been very good at identifying them. It's not always clear where it comes from, in that some of what we need people to do doesn't marry very well with what existing CAD providers provide, and so it's difficult for them to see it as their problem because it's so far away from what their normal products are doing across lots of industries, and so it's sometimes not clear actually where the solution might emerge from, given how the CAD and CAM industry is sat at the moment, because there's lots of, most of those companies are serving lots of industries, and so it's a difficult call for them to devote so much into this. And so, but as I say, we do see mostly relatively small companies coming with very specific solutions.
Kind of startup then?
That's right, and it's a kind of niche application, and if you can sell through to that industry, it gives you a really good platform to then start branching out in other directions.
Matti, what is your experience? A lot of hacks and fixes with the tools existing, or is there something in place?
Yeah, so sometimes, as Ken said, companies come to us, that's a problem, and we find a solution for it. So there's a problem-driven method, but sometimes we also look at the challenges. For example, at the moment, resource efficiency is very important. So as a 4D printing society or pioneer or researcher, we will look at how we can make things simpler. So, for example, in the Formnext, we can see a lot of great robots, a lot of complicated things. But we focus on creating something very simple. So imagine, for example, your XYZ printer is printing this, for example, glass, but we would like to make it very kind of, because we have, for example, 6 degrees of freedoms robot arms that can print a lot of things. But we think about can we print something simple that can change the shape during printing, so we can make things very simpler.
Yeah.
Or when it comes to the biomedical applications, we are working on a project to make the injectable lattice structures that can minimally import to the, for example, broken bones or somewhere that has a bone defect. So we are working on reducing the cost, reducing the complexity, reducing the energy consumption, reducing the need for the electricity, need for the high computational systems. That's. So sometimes we'll see future. So in the future, for sure, we will not have a lot of resources. So a lot of electricity, no. A lot of oil, no. So we think about what's going to happen in the 50 years' time.
Nice approach. A little bit different than the Maxi printer over here, but it's really a good approach. Alex, you as a designer, let me imagine your work. You are not specified or specialized on one certain topic, right? Or on one certain product.
Consultancy, so yeah, it would be generalized.
Yeah, so you generalized. So it's not that Mark only comes to you because you are specialized on textiles, right? So if we see all the challenges for a design for AM, and you are more like a consultant or generic one, how hard is it to understand the different needs from the different use cases? Because I imagine it's totally different between Kenny and the design principles are the same, Kenny. That's what I learned already. But basically, it's different in terms of how to approach it. What is your experience on that?
So the use cases is one of the most interesting things about trying to specialize in additive manufacturing and digital fabrication in general, because within design, the paradigm has been quite similar since the 1950s. You have your tooling made, you produce enough units that you think you can make your money back, and that's been very much the status quo for a long time. So we're now having to rethink business models, rethink innovation, rethink how we relate to the user. Customization, for example, is a completely new relationship between the designer and the designed for. And you could even, with a lot of the conversations in without getting too political, but there's even a kind of power relationship between why is it that the designer should make so many choices about how it is the designed object manifests for people without maybe a more intrinsic understanding of their needs. So additive manufacturing facilitates such a great degree of customization, a great degree of local production, that we need to reconceptualize how it is designers relate to the designed for and what our function is. I mean, even relating to automation as well. We're no longer overseeing the solution side of the design process because that's becoming more and more automated. I think designers have more of a role in the problem identification and requirement setting, which has a different mindset. It's about systems thinking. So yeah, the change in how you approach the design for additive is quite radically different.
You mentioned a very important point, Thomas. That would be a question for you. I'm sometimes missing, don't get me wrong, as I'm from economics, the voice of the customer. So we have, and I the more I think about it, the more complicated I think design for AM is, to be honest. So you have to consider, is it producible? Is it cost effective? Is it for the final usage appropriate, etc.? But then, of course, there's the customer need. Thomas, if somebody approaches you, are you asking, have you considered the customer need? Is that something you look for?
I'm not sure if especially the large companies being our customers would love us coming and asking questions.
Why not?
That way.
Yeah.
But if somebody is open for these magic moments, if somebody is asking for advice, if we say, look, your requirements can't be fulfilled, look, your design is not feasible, and our partner is open to discussion, then this can happen, that you discuss about, okay, what are really the needs, and can we collaborate with experience with these manufacturing techniques, with knowledge about different materials, and understand together requirements and then innovate in a way which goes beyond what we have received. And that happens, but it's within our service the exception. Most of it is print to build.
Good to see that.
But you're right, we have to prepare for it, and that's the reason why we do have designers and engineers for that purpose available as well.
Very good. Kenny, you want to respond?
Yeah, no, I think it depends a little bit how mature the process is before people come to you, and I think, but it's that I was going to give you the phrase I talk to my students about is that so you have to explain that design is impossible until you know what you want to do, and after that, it's not easy, but it's possible. You know, and so the best design projects will spend a lot of time exploring that. Actually, what is the problem? What's our real concern? What are we really about? And it can, from externally, look like it's just a lot of messing about before you get down to the business of doing the design, but it's not. It's the absolutely essential bit that results in great products. Because until you've got to that point, you literally don't know what you're doing. You know what I mean? And so we'll all said it in slightly different ways, if you know what I mean. But that key sort of, right, we're going to spend half of our time figuring out what the problem is, and then we'll solve it. Yeah. And that's a big part of how you go about it, I think.
Dude, we are exhibiting here, and I've shown around people things we have done for other industries, and sometimes it needs fantasy.
Yeah.
That you say, oh, you can print in full color and transparent, and then transfer this possibility, which you are not aware of before, into your area and see what that, because you wouldn't have that requirement if you can't imagine that it's possible.
Yeah, agreed.
And that's where I believe Design for AM makes the difference, that this learning what is possible, can I ask for these requirements, is a change to a standard product development process or this innovation process by designing for AM.
Yeah,
Just if I can interrupt, I really like this perspective because it kind of changes the view of the design process as being a linear thing where, you know, we decide what the problem is, we come up with a solution and we send it to the manufacturer. Well, the manufacturability feeds into what the problem that we can solve can be. So yeah, I just want to second that opinion.
On the other side, Alex, with AM, you could move that boundary, right? I mean, you say manufacturability is a difficult word for a German to say. So let's say feasible to production. Yeah, let's put it that way. So with AM, you might have the opportunity to change exactly that, right?
Yeah, so that having that feedback loop allows you to solve more problems, different problems. So yeah, that new framing actually unlocks a great deal more potential, but you wouldn't be able to make that analysis without the understanding of the manufacturing process.
I think my point is really, and as I'm allowed to be a little bit critical, if that's okay. So if you do, for example, Lean Six Sigma, so Lean management, you try to simplify things as well, and you try to optimize your process. But at the starting point, and this is where we see when we train it, a lot of engineers have a big problem is that the starting point is the voice of the customer, because this is nothing they're used to. They're used to optimize the production or the process or the machine or the material use or whatever, but they're not used to transfer really the customer's opinion. For example, the coffee needs to be hot, simple as that, yeah, into their thinking about how to produce a warm coffee, right? So, Mark, that would be an interesting question for you, but especially with textiles, don't get me wrong, there's sometimes you have the functionality, you have that is feasible to produce, and you have the great materials, and especially in knit structures, there's so many potential, right? And then there comes a client that just wanted to look like that, for example, and then what do you do about the design then?
Well, my own research isn't purely bothered with the aesthetics, so I'm trying to move away from the traditional fashion textiles for aesthetic route to look more at what do these pieces mean that aren't truly knitted, aren't truly textile. So it's kind of a reimagining our relationship with a new visual and material language, and that's quite complex because obviously we all live and wear textiles. We're so fundamentally part of our life. So are 3D printed textiles ever going to have a real place within that? And I'm quite happy to have that discussion. If the answer is no, then, you know, we've explored them. So I also think design is successful if it poses more questions rather than solving everything. So I'm quite happy that you come up with a body of work and then the next part is, right, we've got all these materials and objects now. What are they useful for? Are they useful? And that's another question. And also, we've spoken a lot about the digital, and not to use jargon or get too sort of buzzwordy, but I think the idea of the post-digital is really important. And I think increasingly, particularly within textiles, an appreciation of a tacit understanding of what textiles do, because ultimately they're very physical, tactile objects, is really important to be fed into the design process of the digital. Because even though they're digitally designed, they become physical, and it's what happens to them off the printer when they behave and perform. So I think that fundamental understanding of tactility and traditional textile structures is needed to propel the field forward.
Very nice approach, by the way. It gives you a little bit more freedom, that's for sure. We do have a question from the audience that I want to share with you before the time is running out. So there's a question: do you feel there is or should be an ethics to DfAM? Focus on sustainability, durability, making products that matter. That's what we discussed, yeah. AM makes it so easy to create an option that there is no longer the investment barrier to prevent the market from being flooded with more useless, senseless industrial products. I don't know whether I should say sorry for the question. I love this question.
No. Should there be so that there should always be ethics?
Yeah.
Engineers have to act ethically.
Yeah.
If you don't, then in many, well, actually, lots of buildings fall down because people haven't acted ethically. There are scandals, there are things that go wrong, and so yes, there should always be ethics in a design process. But I'd note that it is also ethical to make a profit. And it's ethical to have a successful business. And so understanding your consumer is if there is a demand there, it is indeed ethical to develop a business which delivers to that demand as well. And then we get to make money and have mortgages and pay the bills and do those things until the bottom. So it's not
a pity thing about it.
It's not unethical to have a consumer-focused business.
Yeah.
But within the context of clearly as societies we decide what's ethical in terms of energy consumption and what kind of policies we need to have around what products are acceptable. But within those confines, that's if you like, a societal problem or a societal responsibility. Thereafter, and as you say, in different ways of approaching the law, but in general, in the countries that we're talking about just now, things that are not banned are allowed. Is the
That's a nice one.
I believe if we design right for additive manufacturing can be an enabler for quite a number of the ethical aspects listed in your question or in the audience question.
Like local production, for example.
Local production, lightweight design, less material consumption, and there are a lot of efforts being done to improve additive manufacturing itself on its footprint and other stuff.
Yeah, very good. One question we haven't tackled yet, and I need to tackle because Connor mentioned it, so you can blame Connor for that. Yeah, we haven't been talking about AI yet, and so yesterday we had a very interesting speech from 10x DNA and venture capitalist, and he showed proudly some pictures with showing an additive manufacturing process, and they were all produced by AI, and they were fantastic. Okay, so to be honest, just a little bit provocative, why I need you as a designer when I have an AI that I can ask, please do me a design of a medical device or do me a design for the perfect knit structure in the future. So, Marty, do you use the other guys? I mean, you can use AI, aren't you?
No, at least in 4D printing is not possible yet.
Yeah.
Because 4D printing is a combination of the smart materials and 3D printing. The smart materials is very complicated. So there are a lot of multi-physics simulation behind it. So you have to control everything. and it's a physics actually. And as far as I use AI as a tool when it comes to the combination or power by the multi-physics, but at the moment, no, it's not like do it for me and then it creates a STL file for you. No.
That's a pity. I wanted to push Kenny a little bit more to be faster.
Well, I can't say. I mean, so generative design. So where you start with a design and then you analyze it and you let it evolve over time is something that we've all seen and heard. It's maybe not widely used, but you can definitely apply AI in that context. When you get to a regulated industry, and that wouldn't just be medical devices, it can be others as well. There's a concern about black box type approaches, because in the end you have to explain to the regulator why your design looks like this and what functionality it has and how that relates back to what you wanted to do in the first place. If the system you're using doesn't give you that traceability, that can be a problem, because you're not clear about actually because if you don't understand what the rules are, you don't understand the limits of them. And so you maybe get to the stage where an AI type of algorithm can run out of scope at the side, and you get to a situation where it's not quite right. And so there's a kind of maybe a level of understanding about the algorithms you're using that you'd need to have in order to be able to use them with confidence in a safety critical application.
At least you need to prove if the design, the rules for design have been applied in the AI as well. Yeah. Alex, are you afraid of AI in the future?
No, quite the contrary. I quite enjoy using it in my process. I think the short answer is, you can ask AI many questions, but how do you know which question to ask? It's about the parameters. It's about, and it goes back to this, trying to identify what the problem is. The AI might be able to generate an excellent solution in terms of the constraints that you set it, but how do you know what the right constraints are? So it also comes down to what you see the design as. I mean, if you're creating, a part for a very specific and well understood engineering problem, then an automated system or an AI will be able to generate that quite easily. But it's not going to be able to give you user feedback. It's not going to be able to understand the context of the product within a brand and within a range of products. It's not going to have an aesthetic touch. So there's definitely a role for the designer. I just think that role will definitely change. I think that change will be a lot more human-centered. It will be about facilitation of the process, and understanding how the automation benefits a wider process. So I'm not going to be out of a job too soon, but my job will change.
That's a good one. Thomas, we were talking a lot of how to create an AM mindset in our industry, because this is missing. Sometimes you probably experience if companies approach you with an idea and you see, oh, there was nobody really thinking in AM. How do we change this mindset? I mean, you're all into design, you are all using it every day, and for you it's like regular business, let's put it that way. Yeah? You follow the rules of design, etc. But how do we get this AM-oriented mindset into the people?
Well, that's a difficult question for a quick end of this talk, but I believe it starts with the education for people how to learn it. It's part of what we do right now, but it's also to improve fantasy by showing nice examples and telling, like you all did, the story behind it. How did we come to this solution? But I believe good samples are the best thing next to the typical engineering education and so on, that people get the fantasy triggered.
I can totally agree, because this is exactly how I entered the industry. It had nothing to do with design, but the first thing my brother-in-law showed me, he was working for EOS, was the Dome of Cologne, a thumbnail big with every single detail included. And I was like, this is possible. And this is the way where I said I want to work in this industry and have something to do with that. And still, to be honest, after that long period of time, in the meantime, I'm still have so many dreams that need to be fulfilled, at least of the four of you, and you, of course, Thomas, in the fulfillment. So it was a real pleasure to have you here on stage. And I learned so much. This was the best part of it, to be honest, because that's what I already felt in our briefing. For me or for somebody that is in this industry to understand the process of design. You know, it's so easy to say, please, Alex, design a new, or Kenny, design a new knee for me, something. That's super easy to say, but that it has to follow a certain process, that's something you need to understand if you're an outsider, not too much into it. So it was a real pleasure. I must admit, this is one of the panels I would love to go on forever. So thank you for that. It was really inspiring. A lot of fun for me. Thank you, guys.
Thank you.
Thank you.
So, ladies and gentlemen, this was the panel Design for AM. I hope you enjoyed it the way I did. It was fantastic in my opinion. We will provide you with some highlights of the fair. So you will definitely see some of the things we just discussed in our panel discussion. And we will see you right back here with the afterwork in about 3 to 5 minutes. Stay tuned and see you there. Thank you so much.